So what we're going to try and do now is see how this formula actually works in real examples, and see how by putting in the limit part of this, it allows us to move beyond the problem with dividing by 0. So we're going to start with this situation. We're going to look at a bunch of different slopes of tangents at different x values through different functions. The first function we're going to start off with is a quadratic. And in this case, we're going to look at find the slope of the tangent at x equals 1. Now, I could repeat this and change the x value and get a different slope of tangent at a different spot. But right now, we're going to look at the x equals 1 case. All right. So we have the function. We know where we're going to do it. So we're going to use our new slope formula for slopes of tangents. And here's where it gets really fun. Because we're using this limit, we have to write out the limit as h approaches 0 every single line of this solution. There's not going to be any shortcuts or anything like that. If you forget, if you forget to write it, you're not doing calculus. Okay, the limit part says that you're doing calculus, allows us to do the math part. So I don't want to see like things like, oh, ditto, ditto, ditto. You're not going to do that. Okay? You're not going to put a big arrow down here and say, trust me, it's all there. Okay? You're going to write it down every time. Because at some point in our solution, we're going to stop writing it down. And that's going to be a significant spot. So you can't all of a sudden not write it at the beginning. We have to wait until that chance to do it. So you're going to love writing limit as h approaches 0. It's going to be your favorite thing to do for the next couple of days. All right. So step 1 in this case, sub a equals 1. Remember, in this particular function, I'm interested in finding the slope of the tangent at x equals 1, so I'm going to plug in the 1. So my first line, I'm going to write limit as h approaches 0 religiously. And this time it's 1 plus h minus f at 1 all over h. Step 2, sub into the function. This will feel just like we did before. Instead of putting in a specific value for h, we're putting in 1 plus h into the function. In this case, it's a nice easy function, 2x squared. So again, we'll write down the limit as h approaches 0. And we're going to plug in 1 plus h into the function. And we're going to plug in 1 into the function. The other thing that common mistake that people make is they forget to write that divide by 0, because you're going to be paying attention to all this math you're doing on the top. If you forget to write that divide by 0, that's a big issue. Okay, so don't forget that part. All right, now I'm going to plug it in. So remember, I'm going to square 1 plus h, so I'm just going to, off to the side, remind myself what the 1 plus h is. You might be able to do this in your head, but I don't want to make any mistakes, so I'm going to do it over here. Rainbow it properly, and I get 1 plus 2h plus h squared. Limit as h approaches 0, 2 bracket 1 plus 2h plus h squared, minus, and then this part's easy, 1 squared is 1, times 2 is 2, all over h. I'm going to rainbow the 2 now. So 2 plus 4h plus 2h squared minus 2 over h. So this is the point where Jonah pointed out, he asked if that constant will always disappear, and he's absolutely right. Last time it was 114, I think it was, that disappeared. Or 171, I think, 171 that disappeared. Here it's the number 2 that's going to disappear. This is a nice little spot to make sure you've done everything right. That constant number should disappear. There's a number of reasons for that, but the one we can talk about is think about what the derivative of a constant is. So think back to our graphing the last couple of days. X equals 2 looks like this, right? A straight line. I should draw it on the board for the people who are watching on the video. X equals 2 looks like this. What's the slope of that? 0, right? Slope of this is 0, 0, 0. It doesn't matter where it is. So the derivative of that is 0. So it's not surprisingly when we're going off and finding derivatives, which is where we're heading towards, that the constant stuff disappears. Okay? The other thing that you're going to notice in a second is all these degrees are going to get one smaller because we're going to divide by h, which is another thing we noticed. All right. Am I allowed to sub in h equals 0 right now? No, because you see that I'm dividing by 0. And I couldn't sub it in anywhere before, so I still have to write down this limit part. But I'm getting really close to the stage that I can. So since those canceled out, I'm left with just this part. And I can now divide everything by h. So this divided by h is going to disappear. This divided by h is going to leave me with one of them left, and this is going to disappear into a 1. And so I'll be left with the limit as h approaches 0 of 4 plus 2h. And now I'll ask, can I take the limit at this point? Can I sub in h equals 0? And yes. Okay? So this part, I should keep up with my steps, sorry. Step 3 was to expand, so we did all the expanding. Step 4, simplify. So we did lots of simplifying. And this is where I'll put in brackets the constants cancel. If they don't, you've probably made an arithmetic mistake. And then step 5, divide by h. And then what we're about to do is something called taking the limit. So we've been sliding along saying that we're doing this as the limit approaches 0, so we're now going to actually, because we aren't going to leave or end up with any divide by zeros, we can actually take the limit and pretend we're at 0. This is where we can get to stop writing it down, because you're actually going to take the limit and you're going to sub in h equals 0, 4 plus 2 times 0, and you'll get the answer as 4. So what we've done is we have done all the work and found the actual slope of the tangent legitimately at x equals 1. Now I could redo this whole question. I could redo this whole question at a different x value, right? And we'd have to start from the beginning and deal with this whole thing. Now in a couple of days we'll talk about how to deal with that. But right now we got to practice this formula. So we're going to practice it again on a new question.